Hey there, everyone. Let's talk about total internal reflection and its relationship to refraction of light and reflection of light. We're going to also talk about its applications and some natural phenomena that happens because of total internal reflection. But first, how does total internal reflection happen? Okay, let's say this is a pool where there's water, as you can see, and here above the pool we have N1 for air. Okay, so I'm going to call this N for air 1 is equal to 1, and here N for the water, and it's definitely bigger than 1. Okay, so N water is bigger than N air, and there are light rays coming out from a spotlight at the bottom of the lake. These light rays, we have infinite number of them, and they can go in many directions, but we are going to focus on one of them. So let's look at this one here. There's a light ray coming out. Okay, we are going to build this normal for it. Since it's coming from a high refractive index to a lower refractive index, the light ray will refract away from what? The normal to the surface. Okay, now let's look at another ray of light coming out from here. And again, we're going to build the normal to the surface, and the light is going to refract away. Since the angle of incidence is bigger than the angle of incidence here, then the angle of refraction here will be also bigger here than here. So as you can see, this light will bend a little bit more. Now let's look at another ray. We're going to increase the angle any more. Okay, we're going to look at the normal, and as you can see, the light is going to be refracted even more. Now what happens if we just increase the angle of incidence a little bit? I'm going to do that here. At some point, the angle of incidence is so big, and I'm going to draw the normal again. So the angle of incidence here is so big that the light refracts exactly at the surface or at the interface. So the light just goes on the interface like this. Any further light that falls, any further light ray that falls at a bigger angle than this one, it will be totally reflected back, such that this angle and this angle are the same. Here, what happens that we call total internal reflection. So that's what we call a total internal reflection. But this ray that is just before the ray that makes total internal reflection, this ray falls at an angle that makes the refracting ray just goes into the interface like that. So if we calculate the refracting angle here, this is the normal, and this is where the ray went. So the refracting angle here is theta refracting is equal to 90 degrees. Okay? This angle of incidence that has an angle of refraction that is equal 90 degrees, this is called theta C, known as the critical angle. So the definition of the critical angle is that angle of incidence or optical media where the refraction of that angle, the refraction angle is 90 degrees. Okay? Angle of incidence refraction is 90 degrees. That's called critical angle. Any angle beyond that will have what? Will have total internal reflection ray. Okay? This condition must apply. Right? The second condition is that the angle of incidence for total internal reflection to happen is that the angle of incidence should be bigger than theta C. Okay, so these are the two conditions that we need to know. Now, what kind of applications we have? We can use those in many optical instruments, and such as, for example, if you have a prism let me just say that this is a prism, okay? And there is a light ray coming onto this prism, falling perpendicularly on this surface. So if a light ray falls perpendicularly on a surface and it goes through, there will be no angle of refraction, it's zero. So the light will continue its motion as nothing happened. But once it falls here, the prism has a refractive index here, n. I'm going to call it n2, and this is n1. n2 is bigger than n1. It's going to perform total internal reflection and goes back here like that. So they use prisms to reflect light in some instruments like periscopes. You know what a periscope is. If there's like a periscope, it's used widely in submarines. So somebody can look here, they can then see a ship here if they want to. So the submarine captain can see the ships from the bottom, because what? There's a prism here and a prism here. So light comes from the ship, gets totally internal reflected into this one, and goes into the eye of the captain. Now, why do we have to put it this way? Why don't we just put a mirror? Because from its name, it's totally internally reflected. If you look at a mirror, and you are standing here, this is you standing on the mirror, and you look at the mirror, you will see your image, but some of the light rays from your picture, from your body, will be absorbed by what? The mirror. So the mirror actually does not reflect 100%. Only very super good, expensive mirrors do that. Most mirrors reflect like 97%, 98%. The good ones maybe 99%. But a prism, when total internal reflection happens, the reflection is 100%, and that's why they use it in this, something like that. Another use for, you've heard of fiber optics, right? So these are fiber optics. They connect between two cities or between two neighborhoods or something like this, where someone can enter a light from here. I'm going to say enter a light from here, and the light keeps doing total internal reflections until it reaches the other side. And that's good because you don't lose any signals, and it's super fast because it travels at the speed of light. So that's another application. There are many other applications. Okay, now natural phenomenon. You've heard of mirage, and that's what happens in a desert. So let's say you are walking in the desert, okay, and you are miserable because you are thirsty, and there's some mountains here and stuff like that, and it's very early morning, okay. In the very early morning, the coldest part will be in the desert. Maybe the coldest part will be the ground, okay. At some times, right? That doesn't usually happen, but in rare times, the coldest part will be the ground. Above of it will be a little bit warmer, and above of it will be a little warmer, and so forth, okay. And you're walking down the desert, you're thirsty and hungry, and there's an oasis here, very far away, okay? There's an oasis, okay, water, palm trees, it's fun, but you're very far away. So the light coming from this oasis, it's going to go up, traveling in every direction, right? But let's say it's traveling. Let's focus on this ray, one ray. It's coming up like this. As it goes from here to here, it goes through layers of air. Okay? And as we mentioned, the layers of air closer to the ground are colder than the ones up in the sky a little bit. In this rare instance, what happens is that as it goes through one layer of the air, it's going to refract a little bit further away. It goes another layer, it's going to refract another layer, until what? Until it hits total internal reflection and it falls down like this. So the guy who's thirsty and hungry in the desert will see the oasis here. It will exactly look like this here. So he will go and run this way, and they will find nothing, and that's why it's called mirage. It's actually not an optical illusion. It happens truly because you see a reflection of something that is very far away, maybe 100 kilometers or 100 miles or something like that. Okay? But why does light does that? Because each here, let's say this layer of air has a higher temperature, so lower refractive index. So this one here, lower refractive index, so I'm going to call this one N1, this is N2. N1 is less than N2, and this is N3. N2 is less than N3, and so forth. Every time it goes through a certain layer of Earth, it bends away from the normal until total internal reflection happens. Okay? This rarely happens. There are more of this happening actually in the poles of Earth. Like usually it happens in the desert, or when you are driving your car on a very long road, you can actually see some kind of like at the end of the road, you can see like it's the sky. It's kind of, you can't tell if the road extends or not. It keeps going or not. You are actually seeing a reflection of the sky, but upside down, because this is another type of mirage that happening from other than the one that we talked about here. And that's it about total internal reflection. Thank you very much.